बिस्मिल्लाहिर्रहमानिर्रहीम। ऑर्गेनिक रिएजेंट सीरीज में आज हम बात करेंगे अबाउट हाइपोहालस एसिड। हाइपोहालस एसिड ये जो टॉपिक है, दिस इज वेरी शॉर्ट टॉपिक बट देन इट्स वेरी वेरी इंपॉर्टेंट रिगार्डिंग द क्वेश्चंस आस्क्ड इन योर CSIR एंड अदर रिलेटेड एग्जाम्स। तो बेसिकली ये है कि हम स्ट्रेट फॉरवर्ड चलते हैं इसकी तरफ। हाइपोहालस एसिड का जो फॉर्मूला हम ऐसे लिखते हैं, दैट इज योर HO and X. So we have basically bond between oxygen and your halogen atom. This is hypohalous acid. When we say it is HX, it's called as halous acid. Fine. So HX is your halo acid, or it's your halo acid. So when you introduce oxygen in between, it becomes HOX. It's called as hypohalous acid. Now if you talk about this hypohalous acid, it also acts as oxidizing agent. ठीक? So what it does, so you basically have this oxygen halogen bond. That halogen can be Cl, chlorine atom, or bromine, but normally it is most commonly bromine जो ज़्यादा use होता है. It is stable also. So when I say hypohalous acid, so in this class I'll be talking about HOBr. So I'll be using bromic acid. ठीक है? So I'll be using HOBr as a reagent, oxidizing agent. Fine. So basically in HOBr, this oxygen is highly electronegative. So it generates this electrophile, that is bromine. So this is your positive part, this OH negative. This is your negative part. Fine. Now, so what they do is, if you treat an alkene with alkene, we know it has a double bond. Because of that pi bond, this is considered to be the electron rich system. ठीक? So what happens? It interacts with the electrophile from the HOBr and it forms this intermediate. This intermediate. So it gets plus here, so it forms this intermediate. It's called as halonium ion. You might have heard this also in the halogenation of alkenes. So it's the same intermediate. It's called as halonium ion. Halonium ion. So now उसके बाद क्या होता है? Once the halonium ion is formed, then the other part, which is your OH negative hydroxide, so it attacks on the backside of this halonium ion. So it attacks on this side, so this bond moves on this side. So it's like SN2 type of reaction. It's an SN2 type reaction. That means we have the inversion of configuration. ठीक है? So what you get finally is, you will get this type of structure. So you have Br here, and then you have OH here. ठीक है? So this is what you get. Now उसके बाद होता है ये जो फॉर्मेशन of ये जो कंपाउंड बन गया, जिसमें one part goes to one carbon atom, another part goes to another carbon atom. ये जो स्ट्रक्चर बनता है, this is called as the this is called the halohydrins. Halohydrins. जैसे in this case it is a bromohydrin. ठीक है? But ये जो रिएक्शन है, it doesn't stops here. What happens? In this case, this bromine gets released as Br plus. So this oxygen attacks here, and ultimately the product formed is this one. You have an epoxide formed. You have an epoxide formed. So this is basically very very important, that we can also form the epoxides by treating alkenes with hypohalous acid. ठीक है? hypobromic acid. So treatment of alkenes with the hypohalous acid, it can give you halohydrins, and from that halohydrin you can also get the epoxides. Now यहाँ जो क्वेश्चन है, क्वेश्चन किस पोर्शन से आता है आपके एग्जाम्स में, अगर आप यहाँ पे थोड़ा सा इसको आप concentrate करोगे, I have shown the stereochemistry of this epoxide. This is bold, so it's above the plane of this double bond. So if you talk about this double bond, it's formed above the plane. ठीक है. Now why is it so? So basically जो mechanism में propose हुआ वो ये है, in order to understand this, that once the double bond which we have alkene, so when you treat this with HOBr, so at the step number 1 it will form this halonium ion. तो halonium ion में आपका जो bromine है, so it will form like this. So it is below the plane. So this is your bromonium ion, it is below the plane. ठीक. Now once bromine is below the plane, then what will attack the other part, that is the hydroxide. ठीक. So you will get this type of compound. So what actually you will get on this side you have so it's on the back side, since this is on the back side, so I will show it here. Back side in the sense that it's downwards. So this is your Br, and now we have a hydroxide here. So this attacks. Now this bromine, this Br atom, it's downwards. So this attacks. So once this leaves, obviously this will attack from the top side, that is above the plane. So your product formed is the epoxide, which is above the plane. So यहाँ पे very important बात है, it behaves like the SN2 system. Now a question ये है यहाँ पे, a question can arise that why we have shown this, that the bromonium ion is formed below the plane. Now depending on कि this bromonium ion will be formed above the plane or below the plane, it only depends on कि what is the environment of this double bond, where is it located. If it is located in that sense that it can also prefer above the plane also. So in order to understand this and solve the questions regarding the stereochemistry, let's take important examples. We'll take some examples, so that will give us idea that how can we solve this question. देखिए, let me take the example number 1. To understand this, let's take the example number 1. So let's take the example number 1. Let's say we have a compound this is your cyclohexane, and then at this position we have an alkyl group, this is above the plane. Now this is a double bond. Now अब ये हमारे लिए understand करना easy होगा, and how can we solve the numerical problems in the competitive exams. देखिए, so I have shown this cyclohexane is a double bond here, but on the adjacent carbon here we have a methyl group which is above the plane. ठीक. So what I will do, I will treat this with HOBr. So that will be our one reaction. So we need the product and also with the stereochemistry. ठीक है. Now on the other side I will treat this with metachloroperbenzoic acid. So this we have discussed it. We know that when you treat alkene with the metachloroperbenzoic acid, that also forms the epoxide. ठीक है. Now as I mentioned earlier, now in this case, first step is that we have to form the bromonium ion. Now bromonium ion, whether it will be formed, that will be formed by breaking this pi bond. So bromonium ion can be above the plane or below the plane. So now if we say it's above the plane, but on above the plane we have on this adjacent carbon this methyl group. So it's not stable because we have some steric interaction. So it will be formed below the plane. ठीक? Now if this group would have been below the plane, then the bromonium ion would have been formed above the plane. So we'll write down like this. Now, because of the stereochemistry of this group here, alkyl group, which is above the plane, so the bromonium ion will be formed below the plane. Sorry, bromonium ion. Okay. So when this is formed, then we are very easy that you have to attack that hydroxide. So that will attack above the plane. Remember this. I will show it like this. That attack will be showed like this. This is bold. So that means bromine is attacking from this top side, because this is below side. Okay? So what it will form? This is your group. So bromine is on the below side. So what you will get is, so I will show it like this. This is your bromine, and this I will show bold. Hydroxide is above the plane now. Fine. Now uske baad this will leave. So this will attack from the top side. So once it attacks, so what you finally get is you will get this compound. This is your alkyl group. So you will get the epoxide above the plane. That's it. So now the stereochemistry, if you see this group and this group, they are both above the plane. That's the compound formed. Okay. So it all depends. Now if this group would have been below the plane, then the bromonium ion would have been formed above the plane and the final epoxide would have been, the epoxide ring would have been below the plane. Okay. So it depends on this group now, the stereochemistry around this double bond, the steric interactions around the double bond will actually determine the compound format. Now if we talk about this thing, if you remember metachlorobenzoic acid, it depends from this metachlorobenzoic acid, it will give us an oxygen, and then oxygen be inserted on this bond to form epoxide ring. So we know that when it will attack above the plane, it will experience the steric interaction of this group, this one. So it will prefer to form the bond below. It will prefer to form the epoxide ring below. So the product in this case will be below the plane. I will show it like this. So that's it. So this is the difference between this compound and this approach. If you treat bromous acid, hypohalous acid scheme, then you will get the epoxide above the plane on the same side. But if you treat this compound with the metachlorobenzoic acid, so then they are opposite. So it is below the plane and this group is above the plane. So this group plays an important role. So this was our problem, which is very, very important. Now let's take out problem number 2 regarding the same concept. So if we have, let's say we have this compound now, another problem. Nar-bornane compound, bicyclo compound. So this is our bicyclo compound. Let's have a double bond here. It's called a nar-bornene now. Once we inserted the double bond, it's nar-bornene. So the suffix is ene, but when it is only the aliphatic, it becomes nar-bornane. Fine. A bicyclo compound. So our scheme is that if we treat this with HOBr on one side, this is our scheme number 1, what is our product formed, and on this side we'll treat this with metachlorobenzoic acid. Okay. So what is the product formed? जैसे मैंने पहले भी कहा कि what is the use of this organic series, reagent series, we must remember at point number 1 what that particular reagent can do, and then what is the stereochemistry the particular final compound will adopt. ये दो चीजें बहुत important है. Once we remember these things, then we can solve the problems easily and know the right mechanism approach. ठीक है? Let's start this. Now जैसे हमने HOBr देखा, alkene देखा, then we'll get what? Epoxide. ठीक है? when we saw here metachlorobenzoic acid, so we'll get epoxide. So only thing we have to worry is this stereochemistry. We have done this earlier also. Agar epoxide, epoxide can be formed towards this side. We need to add this ring here. So this can be formed either towards this side or towards this side. If it is formed towards this side, it's called as exo product. If it is formed towards this side, it's called as the endo product. Now, because of if it's formed towards this side, it's called endo. Endos are usually less stable. So if you talk about metachlorobenzoic acid, you will get the product which the epoxide is towards this side. That's called exo. So if we talk about metachlorobenzoic acid, so the epoxide is formed on this side. This is called as if the product would have been on this side, it's called as the exo, but now this is called as the exo. Agar product yahan se banta, it's called as the endo, because exo is more stable, so the stable product is formed here, epoxide. Now what about HOBr? HOBr mein hame yaad rakhna hai, first the intermediate is bromonium ion. Now that bromonium ion will be according to the stereochemistry, that will be according to steric repulsions. So bromonium ion, two options have, whether it is formed above the plane or below the plane. If it is above the plane, then it will be exo, like this. Exo is stable. If it is below the plane, that will be endo. Endo is less stable. So the bromonium ion will be formed exo. So step number 1. So the step number 1, we'll make it like this. This is your norbornene. So the step number 1 we have is the exo product. Okay. Now uske baad you have to treat this with the hydroxide. So the hydroxide will attack here. Now hydroxide will attack on this side. It will attack above the plane. Remember this. So I can show it by the arrow. Bold arrow, that means it's attacking above the plane, because below the plane we have that epoxide ring. We have this bromonium ring. This is bromonium ion. Okay. So what will finally be formed? So we'll get OH. Then we have this is your bromine. This is your bromine, and this is your OH. And then that bromine will leave. This will attack. From the below, from this side, that is the endo side. So finally your product will be towards the endo. चाहे आप इसे ऐसे दिखाए, doesn't matter, because we are here interested in endo and exo. Even though endo is thermodynamically less stable, but in this case, since we have to follow that bromonium ion mechanism, now bromonium ion will be formed as per the stability. We know that normally the compound prefers to have this type of stereochemistry, that is the exo is more stable. So bromonium ion will be formed as per the exo. So here this bold line even doesn't keep any meaning. You can directly say it is exo because it is towards this side. It's not towards this side. So this is as per exo. When the bromonium ring is exo formed, that means automatically the attack of the hydroxide will be from the endo side. So when the attack of hydroxide is from the endo side, the ultimate product is endo epoxide. So in this scheme, you will get the endo epoxide, that is epoxide is formed on this side. But if you treat this with metachlorobenzene perbenzoic acid, then the epoxide is formed toward this side, is called as exo. So this gives you exo product and this gives you endo product. So this was all about our today's topic, that is the use of the hypohalous acid. It acts as an oxidizing agent. It converts the alkenes into the epoxides. So it basically follows the mechanism, that is the bromonium ion which is formed. So then the product in the stereochemistry of the product depends on this bromonium ion, where it is formed, whether it is above the plane or below the plane. If bromonium ion is above the plane, then the epoxide will be formed below the plane. If bromonium ion is below the plane, then the epoxide ion is above the plane, and then the stereochemistry of the bromonium ion will be determined by these groups around this double bond. Just like we have this one example, I will again discuss this. So we have this alkene where we have a group at this adjacent carbon. This is our double bond. At this carbon we have a group which is above the plane. So now the bromonium ion will obviously allow the attack this double bond from below the plane to prevent that steric interaction. So this is our bromonium ion. Now as bromonium ion is formed as below the plane, so automatically the hydroxide will attack from the top side. So once it attacks from the top side, that means the epoxide formed will be above the plane. So this and this are on the same side. Okay. So that's all about regarding the hypohalous. यहीं से इसमें question आता है. This is from the question have been asked in the past exams. Okay. So this is all about today's topic. So thank you.